before we discuss example 3, I would like to show to you guys what can be wrong, okay, with the example 2. What can go wrong in the solution of example 2? This is based on my past experience with the students. Okay, I can see many students confused with finding the Laplace transform when it comes to the exponential function. Okay, so this is some of the student might do. Okay, so the Laplace of exponent at. So first of all, you write down the integral from 0 to infinity exponent negative st, and then you put your ft. Okay, so up to this. Okay, and then this is the difference that compared to the previous solution. Okay, so here sometimes, okay, students tend to factor out t rather than negative t. Okay, because we are used to factor out the positive value. It is more comfortable to us to take out the positive t rather than negative t. Okay, so if you take out positive t, then in the bracket you have negative s plus a, which can be written in other way around, a minus s, right? So this is mathematically correct, nothing wrong with this. Okay, so now it is the limit. Okay, in terms of improper integral, we can write as limit k from approaching infinity. Then it is from 0 to k now, exponent t a minus s. Okay, so by this integral, so it means we have, so the result is exponent t a minus s, right? Okay, differentiate t a minus s with respect to t, then we have a minus s. And then we evaluate from 0 to k. All right, so now look at this part. Limit k approaching infinity. In fact, I can put aside 1 over a minus s. So I can write like this. So I can put aside 1 over a minus s. Okay, so in the bracket, we evaluate t equals k. So we have exponent k a minus s minus, okay, when t is 0, we have exponent of 0, which is 1. Okay, so when it comes to this, okay, so see here, when k approaching infinity, so students tend to look this part here to be exponent of infinity because k is infinity. Okay, and then so you tend to think of exponent of infinity is infinity, which is true. Exponent infinity is infinity. So then you will write a 1 over a minus s, then this is infinity minus 1. So the overall thing would be infinity. Okay, so this is your answer at the end. Okay, which is not correct. Okay, so in the Laplace transform, we don't have the answer of infinite. We don't have something like that. Okay, okay, all right. So if we go back to this term, okay, in order for us to have the solution, okay, a minus s need to be negative. Okay, a minus s need to be negative. If it is positive, then we'll have exponent of positive infinity. Then the answer would be infinity, which is not applicable to the Laplace transform. Okay, because at the first place, if you refer to the introduction, okay, I've mentioned that, okay, in the Laplace transform, okay, we solve the problem into the domain S. Okay, so we solve the problem in the domain S, meaning that we should be able to get the solution here. Okay, so if our answer is infinity, If our answer is infinity, it means that we do not solve the problem. Okay? It cannot be infinity. So in order to have the solution, okay, the a minus s here need to be negative, so that we have exponent of negative infinity, which is 0. So in this case, a minus s is less than 0. So it means s must be greater than a. Okay? So if a minus s is negative, then when k approaching infinity, then we have exponent here, will have exponent of infinity, but in the bracket here it is negative value. So negative value times positive infinity, then it becomes negative infinity. Okay? So the correct answer that need to be written here is, okay, 1 over a minus s. So here is supposed to be 0 because of this condition here. So we have minus 1. All right. So at the end, we'll get negative 1 over a minus s, which can be written as 1 over s minus a. So at the end, you should get the same answer, okay, as if you are writing take out negative t as minus a. Okay, so it means that it is not wrong to take out positive t, okay, but at the end of the process here, you should aware of this. Okay, this condition is needed in the context of Laplace transform. In order to have the solution in the Laplace, okay, domain, a minus s need to be negative. Okay, and we justify accordingly. If a minus s is negative, then the term here would be exponent negative infinity, which turned out to be 0. So at the end, we'll get the same one. Okay, so I hope you are clear on that. So next time, okay, I think to be safe, okay, you need to always take out negative t rather than positive t. Right? Okay, so I hope you're clear on that. Okay, so we will proceed with the example 3.